One thing about the war in Ukraine is indisputable: the impact of drones. And we're only at the beginning of using this tool, which will become much more advanced with the use of artificial intelligence in the coming years. Interestingly, this drastic impact isn't even coming from the extremely expensive drones that the United States used against insurgents in Afghanistan, Iraq, or Pakistan, for example, but mainly from the cheaper drones whose original purpose wasn't even really military. This is forcing a redefinition of military strategies at an extremely deep level. And that's why, in today's video, we'll look at the aspects of this new type of warfare involving drones and artificial intelligence. But before that, don't forget to subscribe to the channel, turn on the notification bell, and follow us on other platforms like Instagram, Telegram, or TikTok. To keep up with the channel's updates and daily commentary on the geopolitical situation. Your support may seem small, but it's very important to keep the channel alive. I'm Leon Petrov, and you're watching World Geopolitics. Russia's invasion of Ukraine has highlighted the role of artificial intelligence in modern military systems, especially in the use of drones and other unmanned technologies. Both Russia and Ukraine use artificial intelligence to enhance their operational capabilities, seeking tactical advantages in a combat environment that, on one hand, makes engagements much more dynamic, but on the other hand, has caused troops on both sides to become stalled for much longer than usual. Russia has prioritized autonomous systems powered by artificial intelligence to increase efficiency in military operations, allowing for greater autonomy in intelligence gathering, target selection, and decision-making in dangerous or inaccessible locations, thereby reducing risks to military personnel and speeding up tactical responses through the analysis of large volumes of data in real time. On the other hand, Ukraine has quickly adopted artificial intelligence-based drones using commercial technologies adapted to the military context, standing out for their flexibility and innovation in carrying out reconnaissance missions, target designation for artillery, and direct attacks. So, what I presented here in this video was an analysis of the divergent strategies of technological advancements and the operational impacts of integrating artificial intelligence into the drone programs of both countries, focusing on how this technology is shaping doctrinal approaches and dynamics on the battlefield. Historically, the Russian context for the development of artificial intelligence dates back to the Soviet Union, especially in the 1960s when concepts of cybernetics and neural networks began to gain strategic importance. In 1969, Colonel Viktor Bokaryov was one of the first to publish a work theoretically discussing the application of artificial intelligence to military operations, highlighting the complexities of human-machine interaction in combat, thus anticipating debates that are now central to contemporary military strategies. These early Soviet explorations laid the groundwork for Russia's current efforts in military artificial intelligence, reflected in the integration of drones and electronic warfare systems. Back in 2017, Russian President Vladimir Putin emphasized the global importance of artificial intelligence as a determining factor for military and technological superiority, stating that the country leading in artificial intelligence would end up dominating the world. In 2018, the Russian Ministry of Defense organized its first conference on artificial intelligence and inaugurated the Military Technology Park Technopolis, ERA, in Anapa, with artificial intelligence among its central priorities. By 2024, Technopolis ERA had become an important innovation center, collaborating with more than 250 partners and dedicating itself to research in areas such as computer vision, nanotechnology, and modeling in artificial intelligence. A strategic agreement involving Technopolis, the Federal Center for Applied Artificial Intelligence Development, and the Department of Artificial Intelligence Technologies of the Ministry of Defense formalized collaboration in fundamental and applied research, development of advanced software, hardware, and decision support systems based on artificial intelligence. In 2021, the 46th Central Research Institute became responsible for the integration of military technologies based on artificial intelligence, followed by the creation of a specialized department in the Ministry of Defense in 2022. In the same year, the Minister of Defense, Shoigu, approved a document formalizing the strategic role of artificial intelligence in the Russian armed forces. Russian projects in military artificial intelligence have covered a wide range of applications, from mathematical models to optimized logistics systems to neural networks that estimate the lifespan of missile components. In 2021, autonomous systems for the protection of missile facilities were introduced, including robotic complexes equipped with neural networks for identifying and engaging targets, capable of operating autonomously or being controlled by humans. By 2023, about 140,000 drones had been produced by Russia, with forecasts of up to 1,400,000 by the end of 2024 last year. However, these drones faced quality issues which greatly limited their operational effectiveness. The application of artificial intelligence could greatly enhance the performance of these vehicles by automating the detection and destruction of enemy targets. And although the concept of drone swarms is often discussed by the Russian media, these systems still rely heavily on manual control due to the technical and operational limitations the country faces. Today, Russia is testing semi-autonomous systems that allow for better communication and coordination between drones, but the much-desired full autonomy is still a goal they are trying to achieve. In addition, ground robotic systems are also benefiting from artificial intelligence. The STURM program, for example, aims to develop robotic tanks based on the T-72B3 to complement or replace traditional manned vehicles equipped with artificial intelligence for target recognition and real-time decision-making. Despite the advantages of these systems, full autonomy is hindered by very significant technical challenges, especially in maintaining equipment on the battlefield, but I'll talk more about these systems later. Because, despite Russia's advances and ongoing investments, major technical obstacles still need to be overcome for them to achieve full autonomy in drones and military robots, particularly due to the need for advanced sensor systems and artificial intelligence-based visual recognition. For now, human control remains crucial to ensure flexibility and adaptation to unpredictable combat scenarios. Even so, Russia's persistent investment in artificial intelligence technologies reflects its determination to reshape modern warfare, anticipating the future demands of armed conflicts. A central processing unit of these Russian drones is the Rockship RK-3588 processor, an integrated system with advanced architecture developed by the Chinese company Rockship Electronics. This chip incorporates an octa-core central processing unit that combines ARM Cortex, a 76 cores designed for high-performance tasks, and Cortex, a 55 cores which are more energy efficient, thus balancing processing power and energy consumption to ensure prolonged operations on the battlefield. The neural processing unit built into the RK-3588 is especially powerful, reaching up to 6 trillion operations per second, allowing the drone to perform sophisticated analyses using complex deep learning algorithms such as You Only Look Once and SSD, which are essential for automated target detection and classification. The artificial intelligence capability for near-instant decisions allows Russian drones to react quickly to threats or tactical opportunities, greatly reducing dependence on human operators and speeding up the decision-making process. For example, the implemented artificial intelligence can predict the trajectory of a moving target based on data such as speed and direction, allowing the drone to automatically adjust its route and stay focused on the mission. These drones are equipped with advanced sensor systems, although specific details about the cameras are still classified. However, the power of this RK-3588 processor suggests the use of highly advanced camera systems capable of processing infrared and thermal images. These systems are crucial for missions in low visibility environments, such as nighttime operations or adverse weather conditions. Camera data is analyzed directly by the processor through convolutional neural networks, enabling immediate object recognition and the automatic making of operational decisions, such as attacking or evading. In addition, the technological infrastructure allows for extensive connectivity and communication, including high-speed interfaces with HDMI, Ethernet, and USB 3.1 inputs, enabling integration with additional sensors and advanced communication systems. The drone uses the Foxer TRX-1003 receiver operating at a frequency of 900 MHz, using the Express LRS protocol to ensure secure, fast, and stable communication at distances greater than 10 kilometers, even in environments subject to interference caused by electronic warfare. The drone also features sophisticated electronic modules, including flight controllers that interact with internal sensors, accelerometers, gyroscopes, and magnetometers to ensure constant stability and precision during more complex maneuvers, with additional mechanisms such as cameras and other stable sensors that are designed to operate even in adverse conditions, thus ensuring the constant capture of clear images. The propulsion system uses brushless electric motors controlled by electronic speed controllers, allowing agile movements and quick responses to changes in the environment or the target's trajectory. To support the high energy demand of onboard artificial intelligence and electronics operations, these drones use advanced lithium polymer batteries, which are constantly monitored by battery management systems. These systems ensure safety by preventing overcharging, overheating, and excessive discharge, preserving operational integrity during extended missions. One of the most innovative features of these drones is their operational autonomy based on artificial intelligence, especially demonstrated by the use of modern trajectory prediction algorithms. This was clearly demonstrated in October 2024 when images released on platforms like Telegram showed a newly developed computer vision and artificial intelligence system capable of detecting and predicting attacks from enemy anti-aircraft drones. This technology not only detects threats quickly, but also enables immediate autonomous evasive actions, thus minimizing exposure to enemy attacks. The integration of high-resolution cameras with wide-angle lenses ensures broad and continuous coverage, reducing blind spots and improving response time to surprise threats. Additionally, the drone is equipped with sophisticated image analysis and deep learning algorithms that automatically classify objects captured by the cameras as threatening or safe, based on characteristics such as shape, movement, and thermal signature. This system allows for both fully autonomous operations and quick interventions by human operators through intuitive interfaces, further increasing operational flexibility. And in parallel with drones, Russia is also developing in the integration of artificial intelligence, ground robotic systems like the one I mentioned a little while ago in the Chiturn program, which aims to transform T-72B3 tanks into highly autonomous robotic platforms. Different configurations of these robotic tanks offer specific capabilities, ranging from urban combat with rocket-propelled grenades and machine guns, to versions equipped with dual 30mm automatic cannons for fire support or thermobaric missile systems for attacks against wide areas. In all these configurations, artificial intelligence analyzes large volumes of data from its various sensors, making it possible to quickly identify priority targets and optimize its offensive and defensive actions. Although these systems have increased the level of autonomy to track and attack multiple targets simultaneously, the final decision-making for critical actions, such as firing, still remains under human control. However, the role of artificial intelligence also extends to tactical planning, offering suggestions and strategic recommendations to human operators, thus increasing integration and coordination between manned and autonomous platforms. The advances in the autonomy of these drones and ground vehicles have major strategic implications, allowing for increasingly complex missions with less exposure of soldiers to risks. The autonomous capability of these robotic systems not only expands tactical options in the field, but also strengthens the resilience of units when facing unpredictable challenges, such as electronic interference or physical damage. In addition, we also see an innovative technology to recharge drones directly from high-voltage power lines, with a strong emphasis on the use of artificial intelligence. This action emerges as a solution to the critical problem of the limited battery autonomy of unmanned aerial vehicles. This is highly relevant in military contexts, where frequent returns to base for recharging are impractical or dangerous. The technical proposal involves drones that are able to collect energy directly from power lines in the operational field. This allows them to remain on prolonged missions without interrupting their activities. Artificial intelligence plays a fundamental role in this process because it ensures the precision, safety, and effectiveness of the operation. Through intelligent energy management, drones can recharge themselves in the very environment where they are operating, ensuring that the operation is not compromised by frequent returns to base. This capability also enhances the strategic use of drone swarms, since artificial intelligence algorithms analyze battery charge levels in real time and automatically direct each drone to the nearest power lines. With this, it is possible to ensure broader territorial coverage and an almost uninterrupted operational continuity. These are aspects that are extremely valuable in prolonged military missions or in hostile territory. In Russia, the development of this technology is being driven by specific projects such as Troyogolnik or Triangle, developed by the Butuchego laboratory. This project features a special mechanism equipped with insulating claws that, when installed directly on power lines, allow drones to be received, positioned, and charged in a safe yet highly efficient manner. But despite this idea being quite promising, the practical implementation by the Russians has not yet shown concrete results or become clearly operational. Just to give an example of an existing practical application of this technology, we have a study developed by the University of Southern Denmark, where the focus was on how drones could collect energy from high-voltage alternating current lines, without needing to establish direct contact. The technical solution involved two main methods of non-invasive collection, inductive and capacitive. In the inductive method, the drones capture energy from the magnetic field around the power lines using specialized internal coils, which induce an electric current that is then stored in batteries. The capacitive method, on the other hand, uses the electric field generated between the lines and the drone. It's less energy efficient, but useful when the inductive method can't provide enough power due to limitations in physical proximity to the lines. Now, regardless of the chosen method, it's necessary to use highly sophisticated energy conversion systems, including alternating current, direct current rectifiers, and direct current to direct current converters, which regulate and adjust the voltage to appropriate levels for charging the drone's batteries. In this process, artificial intelligence is essential because it dynamically manages the entire energy conversion process, modulating the conversion rate to avoid overloads or damage to the system. Artificial intelligence is responsible for continuously monitoring the battery charge level and the condition of the electronic components. And it also manages the efficient distribution of energy between sensors, cameras, communication systems, and the drone's flight. Another aspect managed by artificial intelligence is the positioning of the drones near the power lines, a very delicate procedure that requires precision to avoid electrical discharges or structural damage. For this, drones are equipped with various sensors such as global positioning system cameras, light detection and ranging systems, and inertial measurement units or IMUs, where the data is processed by artificial intelligence to maintain a stable and safe position throughout the entire charging period. In situations involving direct contact, like in the Russian project, specially developed insulating claws are used to protect the drones from the high voltages present in these lines. Additionally, artificial intelligence responds to fluctuations in the electromagnetic fields of power lines, which can vary depending on the electrical grid load or different weather conditions. Faced with these changes, the algorithms adjust the energy harvesting process in real time, ensuring the drone's safety and preventing operational failures. Artificial intelligence also constantly monitors the temperature of critical components such as inductive coils and voltage converters, activating cooling systems or temporarily suspending charging if necessary, thus ensuring the integrity of the batteries and other components. But of course, we also have Ukraine, which is also making strong advances in the development of drones with applied artificial intelligence, although not as much as the Russians, especially through projects like Brave One. This initiative involves direct collaboration between government agencies, the tech private sector, and Western companies, with the goal of accelerating the production of highly automated military drones. The Brave One project stands out by promoting the development of emerging technologies such as drone swarms, guided munitions, and quadruped robots, the famous robot dogs. The swarms use artificial intelligence to coordinate collective actions on the battlefield, analyzing environments, avoiding obstacles, and evading enemy attacks autonomously. Guided munitions, on the other hand, drastically increase the accuracy of attacks by automatically adjusting their trajectories even against moving targets. Quadruped robots are mainly used for logistics and reconnaissance, capable of carrying ammunition and conducting reconnaissance in hard-to-reach terrain. Artificial intelligence is widely used in Ukraine to automate crucial processes such as target recognition, threat evasion, and real-time decision-making. And given the massive inferiority in artillery, the Ukrainians found a temporary substitute in drones. With advanced learning capabilities, these drones have greatly improved their operational performance over time, especially in highly hostile environments, as they store and process past events. Advanced techniques such as computer vision, neural networks, and specialized sensors are used to enable operations in adverse conditions, like low visibility or nighttime missions. A practical example already implemented by the Ukrainian armed forces is the drone Seeker Scout, which automatically identifies camouflaged enemy vehicles, immediately transmitting their coordinates to Strategic Command. In addition, Ukraine also works with autonomous ground drones and systems capable of intercepting enemy drones. But despite all this, it's important to keep in mind that what we're seeing are just the first steps in the integration of artificial intelligence with drones on the battlefield. Ukrainian territory is currently a crucial testing ground for these new technologies to be experimented with. So in the coming years, we will soon see even more effective and lethal systems. Thank you all. I hope you enjoyed it. And a special thanks to the super members Lucas Silva de Souza and As Portas da Cidade. Don't forget to subscribe and share the video with everyone you know to help the channel keep going. Your support is very important. Hugs, and see you in the next video.